When you ask questions, and please go back to the note taker to make sure your names and affiliations are clearly recorded. If it's not, please add it yourself. Everybody is encouraged to write notes in the IETF note page. Okay, so first is the note well, and I hope that you have seen this page before. You are in this room participating. Be aware of the notes well identified here. Next page. So computing aware networking is a pretty big area, and this has been sorry. We had a ball 2 IETFs ago, and this time the proponents have narrowed the scope of the work, and they make this to be the home to discuss how the availability of computing related resources, this is not just computing, but also storage or something else associated with the places or sites which host the compute servers, how they impact the routing decisions. So mainly focusing on the routing aspect, and focusing on service instances that with one address going towards multiple destinations, typically known as anycast, within one administrative domain. And here are some useful information. Mailing list, can@ietf.org. Encourage everybody here to sign up, subscribe to the mailing list if you have not. And there's also the information about what it is, the GitHub, which has information about the scope and some of the experiment they have done by the proponents. Okay, next page, please. So the focus of this BOF, I want to make sure that this is not for discussing solutions, but primarily to demonstrate the problem space and to make sure the community is aware of what problem to be solved, and also get the agreement if IETF is the right group to attempt to solve the problem. And second is, do we have critical mass, enough people willing to contribute, and including writing drafts or review other people's drafts to any future potential solutions or other things included. Another important thing for this BOF is to make sure the scope is very well defined, and make sure we don't boil the ocean to do everything under the sky to solve this problem. Okay, so so for this, make sure everybody's clear that this BOF is for problems in the routing domain. Next page, please. So here's a brief agenda. We have proponents present the use cases, scenarios, and problem statements. And there's also another one for the gap analysis. Yes.
Can I interrupt for just a minute? There are a lot of people clustered by the exit, probably in contravention of various fire codes, I'm just guessing. There's a lot of open seats. If people next to open seats can either raise their hand to indicate or shift in or something, that would be helpful. Thank you very much.
Thank you, John. And then we'll have a quick discussion of the current proposed charter, and then we'll have a big chunk of time for the charter discussions. Then we'll have AD giving a few words to wrap it up. Thank you. Next page. So with that, I think we are ready for the use case and the requirement discussion. So let's bring that. I think it's Louis, right? Presenting the use cases, or Peng, both of you, okay.
While we're teeing up this speaker, just a reminder to everyone that if you're not actively eating or drinking, please remember to raise your mask up again. Thank you.
Okay. Pony from China, and I will present the use case. So, first, next slide, please. First is the history about CAN work. It was development from the DICAS work, which has 3 side meetings from 2019, and talking about use case and also some technical details such as flow affinity. And then we have non-WG CAN BOF in IETF115. Fortunately, we get a pretty good result about the use case, but not get a consensus about the solutions. And we also received 36 issues, and we respond to them to the mailing list, GitHub, and also copied to the questionnaires. For the last IETF meeting, we present the progress in the RTG area and TSVWG to promote more consensus. So in this both, we focus on the problem space and use case based on the levels of consensus on them have been reached, and so many operators and vendors are interested in this work. So we also hope that no solution discussion in this both. Next slide, please. So now we focus the CAN work on routing area. It considers utilizing the computing-related resource conditions in traffic steering decisions. Specifically, can focus on impacting routing decisions through propagating the computing resource metrics to interested nodes. For instance, the ingress nodes. Wait, next slide, please. So here's a quote from our responsible AD, John. He said the outcome of the previous BOF was that there was support that the problem is legitimate, but there was no consensus around the approach being proposed for solutions. So therefore, guidance this time around was to focus on the great part, the problem, and going forward, people with solutions can make their case if a WJ is chartered. And here's our considerations. There are many non-routing based solutions out there, and there are other IETF working groups working on the non-routing based solutions. But those solutions are not enough for some scenarios which are demonstrated later. And we are making a case to have a very narrowly scoped WG to address how remote metrics impact routing decisions, because we don't want to boil the ocean. Next slide, please. It shows the rapid development of the integrated ICT infrastructure. Different from the past, the operators are offering the integrated computing and networking infrastructure. Some CDN nodes has been installed, and this node can be upgraded to visiting and then edge computing infrastructure. And difference is that more diverse computing resources needed to be provided comparing to the original content providing service. There will be more edge computing nodes set up in an on-demand manner. Here's a typical analysis result showed that so many edge computing nodes will be settled in the content aggregation, access aggregation, and on-site. And now China Mobile has around 1,000 edge sites in more than 200 cities, and 200% increasing rate comparing to the last year. And in China, there's at least 2,500 edge sites of operators to showing the increasing service providers over in the infrastructure. Next slide, please. So why does edge infrastructure develop so fast? Because users want the best experience, such as low latency and high reliability. The emerging new services such as AR and VR, intelligent transportation shows that, and user also wants stable service experience when moving around different areas and in times of changing demand. the mobile network brings more convenience for the users to use a lightweight UEs to get more service. And how to meet user requirement? One point is to deploy instance for the same service across various edge sites for the better availability to provide the functional equivalency. And another point is steer the traffic dynamically to the best service instance, because traffic is delivered to the optimal edge site based on the information that includes the computing information. At the same time, the definition of best may be service specific, maybe the appropriate one. Yeah, next slide, please. Though we have the thought about to meet the user's demand, the reality is computing has advantage of closest, but in some cases, the closest is not the best for service because of the virus of the computing status. The closest site may not have enough resource, particularly when load fluctuates. And the closest site may not have enough specific resource. For example, support for the specific hardware or software, and which will explain in the later. Yeah, next slide, please. And here we use 3 slides to show that the traffic steering based on the computing resource variety. Yeah. So it shows a common deployment of the edge computing. The edge data center in the metro area with high computing resource provide the service to many UEs in metro area, especially in the working time, because there was office buildings in the metro area. And at the same time, there was also the limited computing resource in the remote to provide the service to the few UEs close to the remote edge site. And in this case, the service request and the computing resource matched well, and there was only some potential traffic steering if needed. And please remember the location of the UEs, which will move in next slide, please. So in the non-working time, for example, in the weekend or the daily night, the UEs will move from the metro area to remote edge because maybe their house was close to the remote edge. And there will be more service requests close to the remote edge, but the computing resource is not enough. So some traffic need to be steered back to the metro center. And it is only for 1 or 2 days can't justify adding servers to the remote site. Next slide, please. And here also shows a case that some sudden event, for example, some shopping day or the vocal central activities to make the traffic need to be steering among the different edge sites because it's also unplanned and you can't find the regularity of the UEs move. So this shows another case for the traffic steering. Yeah. Next slide, please. And here's the first considerations. The high computing resource needed by UE at remote site for a short period of time, which is not long enough to justify adding more computing resource at the remote site. So the traffic may be steered among different edge sites. So this is the first part of the use case. And for the next part, welcome Luis from Telefonica to present them.
We'll take a short pause here so that people in the back can find their seats.
Okay.
Just one second. Folks in the back of the room, please find a seat instead of just staying at the door. Oops.
Okay, so can I continue, right?
Yep.
Okay. So yeah, I will present a couple of use cases. So the idea would be what are the factors to be considered at the time of steering traffic. So we will try to illustrate this with the use cases, where the overall idea is to take into consideration not on, I mean, to go in, to enrich the decision, combining information from the application side, from the resources side in the edge, but together combined with the information in the network side as well. So next, please. So as a for example, we can consider this of computing aware, augmented reality, virtual reality. So in any service, we will have for sure to access to an application, to a service function or a number of service functions delivering some service. So we will have some dependencies. We will have dependencies on the kind of terminals and processing time that's spent on the user side, similarly to the application side. And also we need to have into consideration the time for reaching where this application is running, in order to consider the delay budget that we have available. We cannot do too much on the terminal side or on the processing side. For sure, there could be ways of optimizing that part, but we can consider those as static and probably out of the control of the operator. So the only thing what we can play with is the reachability, how far or how much time we can spend from the budget delay in reaching a specific service. So in the sample that you can see there, we could consider that we have the different applications in 3 different edge sites. One of them imposing a delay of 9 milliseconds, another one imposing a delay of 4 milliseconds, and a third one imposing a delay of 5 milliseconds. So if we consider as fixed the time employed by the client in order to processing and do their job for consuming the application, we see that the only option, at least in this particular case, would be one of the 3 edges. So if we decouple or if we take the decision, or the application takes the decision, decouple from the information of the network, could be the case that the application could decide to select one of the other 2 instead of the optimal one in order to fit to the delayed budget. Next, please. This will be another example where it's important to take into consideration the combined information between the network and the application. As I mentioned before by Pen, probably here we have a case where there is a number of cars moving around and having available a number of edge sites for retrieving information. There will be applications that could require low latency, so others that could require high bandwidth. So in principle, we could have, these applications could be served from the different edges. However, not always the closest edge environment would be the best for the service. Maybe because we don't have enough resources for processing the information, and maybe we could affect some decision of the systems and so. So in this case, we try to simplify that point, that the idea would be to select the best one with enough resources, enough capabilities for satisfying the low latency requirements, but also the high bandwidth requirements in such a way that we don't affect the application, but also respecting the overall delay budget. So finally, having this combined optimization between the transport side or the network side, sorry, and the application side as well. So next, please. So essentially the point and the key message on these kind of services that combine resources and in the network side and also in the compute side is to have a combined optimization and a combined decision that could consider simultaneously the network and the compute part. So moving or transitioning from the decoupling decision that we have today to an integrated decision considering both parts. So next, please. So the takeaways from the use cases that I commented, so essentially the traffic can be steered among different edge sites. So we have somehow the possibility of designing a web. So, and this opens the possibility of optimizing such a decision. And for that decision, essentially we need to consider the impacts on the compute side and also the network side. Next, please. So this slide summarizes some some other interactions that we had in the previous months. So there are other activities in other bodies. So how the idea here would be to leverage on IETF for defining the solutions within the routing area. Also, it's important to highlight the fact that the compute environment is something very much dynamic. It's diverse in terms of solutions, but also is varying along the time because the different applications could be consuming different resources. So it's somehow very, very much dynamic. So this is why it's important to have this possibility of combining and trying to optimize both together. Let me just highlight the latest point in the lower part of the slide. So we received an important number of comments and issues in the GitHub, 36 of them. So we have tried to answer all of them. This does not mean that the issues has been closed. The discussion is open and yet ongoing. But just to highlight the point that we are generating too much discussion on this topic. So next, please. Well, okay. So that is the latest one. Thank you.
Thank you very much. Is any clarification questions? Any?
Hi, Dan Bogdanovic. So I'm curious, APN was canceled. What's the difference between CAN and APN? Number one. Number two, what was presented here is more or less policy-based routing. You define the policy based on that policy, the traffic is being routed. What is part of that policy can be multiple things, not just latency as an example. So that's the one part. The use cases that we're presenting, especially one with the self-driving cars, too much into the future. What would be some of the real use cases that would today will be really driving what is the right policy, or what would be the semantics to create the right policy for the routing?
So that's a lot of questions. So, so like 3 questions, I put it down. So make it simpler for the presenters, especially they are not very good native speakers.
Yeah, I mean, maybe you should just like refresh because not everybody was in the room when you sort of laid out the meeting plan. Like, you know, there's a bunch of time for like big picture discussion at the end, correct?
Yes, yes. Yeah, so we do have longer discussion at the end with the charter, and maybe the APN, maybe difference to APN will be covered. Right now, just to the use cases they presented here, any specific questions? So we do have questions on the queue. So, Keaton?
Hi, Ketan Talaulikar, Cisco. My question, which I also put in the chat, is this all about Anycast destinations, or is there something else as well?
Is it about Anycast?
Yeah. Should I answer? Yeah.
Yes, please.
Okay, I will answer with my personal view. So this is somehow the problem statement. We are not yet entering into solutions. Probably there will be different options for that. Anycast could be some of them, but probably could be others as well. So
Okay.
not only
So
limited
if this
to
is
Anycast, I guess.
okay, so I understand it's not limited to Anycast. In which case, this is about picking of or selection of the destination addresses as well, right? For the application or use case. And then my question would be, isn't that outside of routing space?
So the last part.
He's saying that if it's not about Anycast, then it's outside the routing. So let's defer that to the end of the charter discussion.
So yeah,
Okay.
just to repeat,
Okay.
if it's about applications using destinations based on some metrics or some other criteria, then would that not be outside the routing space? That was my
So
question.
let's discuss that afterwards. So next one, Chen Li on the list. Oh, Tor.
Yeah, actually, I think we should focus on the use case firstly in this presentation. Lots of questions related to the solutions should be, deferred to the next meeting maybe. Yep, thank you.
Okay, so next one is Peng.
Can I? Yeah.
Oh, Taurus, you want to say something?
Yeah.
Okay.
Thomas Eckert. So very early on, when we started to do routing protocols, we're implementing in things like EIGRP, measured load aware routing, And then the consumption of the path, changed the load so that we would get into a lot of fluctuating behavior. So I'm wondering, how you would frame the problem so that you make it clear how the consumption of the services you're discovering and the impact it has on the quality of the path are taken into account, or, how you think you have solutions to avoid the fluctuation and other problems we had in the past.
I want to ask, cut in for 1 second. So we have online participants, and so everyone in the room, please also use the queue online tool to get in the queue. That's signing is also another way to track the participation, the blue sheet. So please sign in, even if you're in the room.
Okay, so Pen, it's your turn.
Okay, so for the technical issues, we also have the gap analysis in the next presentation. And for the use case, we think the two typical use cases we showed is not really far away from now, because there are some deployment in the city, and we can see them. And for the AR and VR, it's really a strict demand for the 20 millisecond, and it's just because there's no joint consideration. So that may be some obstacle for the really to provide at this time. But we really to get a use case that is broadly to see in this stage, including the edge computing. Yeah, thanks.
Okay, so next one is Tianji. So have you signed up for the list?
Okay. Can we just leave this discussion until I finish my presentation on the gap analysis and the rack? They have laid the foundation about use case problem statement. And then now if I can talk about gap and also requirement, maybe people have more idea or comments. Thank you.
Okay, so next one is Rang Pan. Is he online?
I agree with part of the use case, such as computing aware VR AR application, and I'm interested in autonomous driving scenarios. I think the autonomous driving scenarios should consider more mobile elements such as UPF, but it indeed is a potential scenario for CAN. Thanks.
Okay, so is that Kwon Lee? Do you want to answer the question, or?
I couldn't get the question.
Oh, I couldn't get the question. Okay. So Kwon Lee, are you
Can you
online?
hear me?
Yes.
I'm online. Okay, I think it's important to consider the computing and network relay together to provide an integrated service, ISP. In addition to the use cases he mentioned, there is an industry control scenario in the industry internet in which computing tasks need to be performed in edge cloud or regional data centers, and these tasks need to guarantee a certain time delay to achieve the current industry control. So I agree with the use case. Thank you.
Thank you. So your name and affiliation, please.
Marco Lieb, probably a pretty fundamental clarifying question, very brief here, but maybe it has been answered already. But it's not so clear to me when you talk about applications. So what's the expectation of an application from the network to take a decision, right? So is it plain resources in terms of compute storage, or is there an expectation on the availability of a function that uses that storage? So is it kind of serverless communication that we assume here, or do we assume something existing in the infrastructure more than the compute storage resources, which is a network or an application function? Which is relevant for your question that you had on the slide before. What is a decision criteria, right?
Yeah. So when considering the application, so what we are considering is the availability of the same kind of workload in different places. Serving, so it could be in the form of serverless or whatever other form. So somehow we need to deal with the reachability to those applications or functions or however you could call it. So it's such a way to guarantee that we can accomplish the SLOs that are requested by the user at the end. So in some cases would be the accessibility to the functions. In other cases would be the guarantee of the resources maybe for doing some processing and guarantee maybe an improved behavior of the application. So in these kind of decisions can be taken alone by the application. So deciding, for instance, thinking on a streaming video solution also, deciding what kind of cache would be the one delivering the content, or being combined with the information of the networks in such a way that the decision is enriched with the circumstances of the status of the network.
Yes, we should.
Okay. So the definition of resource goes beyond compute and storage, but includes a certain function that is expected by the application, right?
Yeah, at the end, I mean, could be only the. Well, I would say yes. In general, yes. Yeah.
Okay. Thanks.
Okay, so so Dirk is the next one. Dirk Troelsen.
Sorry, I did use the actual tool for the room. There was a question about the use cases before and a reference to the use cases maybe being a little bit far out. I mean, as one of the examples, we ran about 25 different trials in EU-funded efforts on edge computing, where we asked application developers to develop use cases in AR, VR, mobile gaming, smart tourism, to deploy their application in an intelligent environment, which happened in 3 different places in Europe. And it's interesting to see when Luis makes a statement about the expectation of best instance to be chosen is quite different in those use cases. And a lot of these application developers come from an application paradigm where just pushing this into a central cloud gives them an infinite capacity, but now suddenly they're pushing it onto a base station which has 12 cores, and suddenly they really have to calculate very well, what kind of service functionality gets there. So that material is available, and I'm very happy I know we didn't have enough time to bring this properly into the use case draft, but to cite this in the use case draft, these are great insights from an application development perspective as to what you expect and how the network maybe struggles to really fulfill those requirements properly. Thank you. Just wanted to give that a comment.
Johnny from Huawei. So thank you for the presentation. I just want to mention that we seem to forgot to mention the name and the affiliation before make the comment. So we should follow the rules. Yep. Thank you.
Thank you. So now, thank you very much, Luis. So next one, we're going to present the gap analysis by Tianji from China Mobile.
Yes. Okay, from Peng and Louis' presentation on the use case and problem statement, there are a lot of questions already. So I can expect there are more questions after I'm done with my presentation. With that in mind here, I have to emphasize in the previous slide, Peng and Louis have laid a very solid foundation to demonstrate 2 important and critical points. The first one is there is a problem. That is the first takeaway about, okay, something has to be done to optimally steer traffic. Okay, based on, you can call it intelligent or kind of like a component, those type of things. The second they have laid down from there, the second takeaway is regarding to use a joint, some matrix, like using networking information, compute information in a real time mode, and also to through some effective ways. Okay. So with that one here, I will give some gap analysis. This is based on some existing solutions. So basically like, okay, so let's look at some existing solutions to see whether they have at least partially addressed, but might still exist some deficiencies. Next one. Yeah. Before I delve into the details and the categories into different existing solutions, here I give a slide to do a pre-summary about the things. Here I give the examples. Some categories, not just you can assign that as a categorized example, like the DNS, like a load balance, like auto, like a client-based, well, because some people keep mentioning about application, how application can do this, can do that, and the policy-based. So I will put that one also in one category. So, but if you look at all the things, there is some commonality to those existing solutions about the exposure and the usage of networking conditions. And but the thing is, if you put this thing together, we call it like interaction approach. More later, you're going to say, okay, we call our it's not solution, but the CAN thing is like on path, whereas the interaction means there are some pre-intelligent work that have to be done in order for the successive work to proceed. And also for all the existing solutions I'm going to present next, I will consider them lack of the integration of the computing resource conditions and the networking conditions together. So with those things, well, here I just give some implication about something we want to achieve, but the existing solutions are lacking of, like dynamics of service relations, exposure of holistic metrics, and also efficiency and the complexity to reduce complexity of cost. Next one. Next one, please. Yeah, this is the first category about the we call the DNS. Another is the global service load balance. So for this category, there is the first one is the point is like early banding. The client has to resolve the IP address first. Yeah, and move a little bit here. Keep. Okay, the client has to resolve IP address first, and then only after that will the client get the chance to send the traffic. So here, well, remember they also use some effective way and also to get some real-time property or characteristic. So this one is not the ideal for this case. And also remember here we call the interaction, the DNS things. It's a resolver or DNS, well not on the traffic path. So it's going to cause the message signaling, the signaling burden, and also message distribution, all kind of things. In order to remember here, it's not just like the time granularity is very small. So for our objective, and also some health check for the service instances has to be done. So this is also a deficiency for this type of things. There's like a load balance through the DNS work, like the DNS SD, multicast DNS. We do give credit for both, but we consider them all on the line in the LAN environment. Well, here, we are looking at one scenario. So they also got the DNS still cache the things. This is the first category about existing solution. Next, please. The next one is about load balancer. It got like no matter like layer 3, layer 4, layer 7, and all kind of things. We categorize, we put them into two buckets. The left one is a single load balance in a single site for all the server instances, and the right figure give the multi load balancers distributed or geographically distributed among different edge sites. For they do have a prongs like either. They are easier to be deployed, but they do have a cons. For the left, for the single LB case, and then you can one thing in a single point of failure, or the other part like called a path stretch. Like you put the load balancer at one edge site where you may have service instance on the other, or on the server side or other sites. So this one, if you look at the left picture, you got a red dotted path. For the right picture, it's a multi load balancer case, and then the thing here you got the orange, the red, and the green. So they have to find some way to do this type of the distribution of the load out toward the optimal. We keep calling the optimal service instance. But here it's like, okay, for all the three different LBs, they have to find some way to exchange message, to go through some signaling protocols in order to achieve the target. Next one. Yes, this is the third category about the ATO. It's an application layer traffic optimization. So this is called the off path. So for the client, in order for client to get the best, the optimal service instance, it has to ask a scheduler, which ask a auto server. The server will do all kind of intelligent work or to do the task to collect information from the service instances from different edge sites. Okay, so here is going to involve, remember for the takeaway. The second part, we want to get an effective and efficient way in a real-time mode. So that is important part. For the auto, it's like the off path. So it still bears the deficiency, or still bears something we are our CAN are targeting for. Next one, please. This is the last one, a client-based solution, as people here will got some questions on the application part. You can consider it's like the client side is a sort of like application, but the thing here is like you ask the client to do all kind of intelligent work. So it has to find some way to get the real-time information, and so that the client can do the selection. Of course, there are lots of challenges here. So the things like the first one actually, we will consider is the most important as the largest mobile operator. Actually, this is common for all the service providers. Like you do not want to expose your domain or some confidential information toward a third party UEs. Well, maybe you can argue the UE has already subscribed to our network to subscribe to our service. But the thing here is like there are some roaming, the things like, okay, they are confidential information. And this is a very valuable asset for us. So that one cannot be exposed. And the other thing is like there are so many applications or services. You do not want the client itself to do the work. So it's remember here, our CAN is not specific to any particular service. It's just to try to give a kind of the framework or architecture, those type of things to solve the two takeaways in the previous slide. The previous slide has laid out. Okay, next one, please. Okay, so here until now, I have gone through 4 different categories of existing solutions. The first one is like a DNS based. The second one is a load balancer based. The third one is the auto. You can kind of like application sort of things, and the fourth one at the client, and also consider sort of including both applications and some other ways. So here for the existing solution until now, we are consider, okay, well they partially at least I will acknowledge they do address partially the problem scope we have laid out here, but when you put all the objectives together, so like dynamics, like efficiency, like complex, the challenge of complexity and accuracy, as well as the metric exposure and usage. So when you put everything together here, more or less for each different categories, you can see the gap analysis. You can see the gap. The gap does exist in different existing solutions. Well, okay, the next one. Yeah, so with those things here, I'm going to lay out some requirement for the CAN. Next. This is the goal we want to achieve. The thing is like, okay, so remember in the previous user case and the problem scope slide, well, we lay out, okay, we want to find the optimal one. So the first goal is to consider to access one of many possible instances deployed across multiple sites. The second one is the multi-matrix. So it's going to jointly consider both the networking and the computing resource status. The third one is regarding the dynamic decisions. Select the appropriate computing resource dynamically. So this is the 3 goals, and we want to achieve. And then, can you go to the next slide? Okay, Greg, I think I'm going to answer a question, but never. I think I have 2 or 3 more. So, yeah. So this is the 5 bullets here with some sub bullets are the potential main requirements we're going to we are laying out here for the CAN. So the first, is to support access to available edge site dynamically, and then the next one will to jointly consider the network computing metrics. The third one is to support effective computing resource representation and the in-cap. You can consider like message signaling and some protocol extensions. Well, I'm not talking about solution here, but this is some sort of like signaling things in mind here. And also we want to support the session continuity and the service continuity called SSC here. And if for the CAN, and if we want to select the best or optimal service instance for some end device with service with the offering like the roaming service, and then here will SSC service continuity and the session continuity will be very critical. So this one is also as one of the requirements. The last one I have to talk about in the client-based solution, and then the provider want to preserve the confidentiality about we can call the service or the valuable assets, all kind of things. Next one, please. Okay, so here is some questions that have been asked through the past BOFs, the SAM meetings, the email discussion from the diecast email discussion, CAN discussions, and all kinds of the things. Here, I'm not going to go through the details, but it's showing, okay, people, there are a kind of a question that have been asked. And the next one. I think that one will be the last. Okay, this is the slide. Okay, that showing the people who have contributed, who have commented, or who have worked one way or the other on the CAN. So by this moment, combine this the 2 presentations, the Peng's, Louis, and mine here, unless the way below, we can answer some questions. The first question is there a problem? Yes. Is the problem scope clear? Yes. There, from this slide, is there a critical mass of participants who have showed interest one way or the other? Yes. And then is there a space in IETF for this CAN to form a group? Yes. So the next will be the charter discussion from Peng. Thank you.
Thank you. Now we go to the questions. First one on the queue is Tom Hill. Please state your affiliation.
I will. Thank you very much. I'm Tom Hill from BT. I'm very interested in VR. I think it's actually really cool. Everyone wants a good VR experience, so I can entirely understand why we need to signal information about good processing, abundance of processing resources on the network. Cool, completely understand that. If we are going to signal metadata or meta information about resources on the network, we can do this in a few ways. We can do this inbound, we can do this out of band, or we can not do it at all. In theory, you could just have too much capacity and it won't be very efficient. It strikes me as very strange, though, when we're being asked not to discuss solutions, that this is being formed in the routing working group. It seems particularly ominous. But also, if this is going to be a routing-based solution, how do we actually inform handsets such that the applications know what to do? Because there's a disconnect there between having multiple applications for VR or AR, and a network understanding that this company's computing resource is different to this company's computing resource.
Okay, I think you asked a question about how the network in our scenario should inform the UE or end devices about this intelligent. Is that right?
Yeah.
Okay,
It doesn't seem like it's a routing solution as such. It seems to be something that's an out-of-band signaling.
You know, the things like I can answer your question here for us, the mobile operator here. There are different ways to do the work. But the first part is still like on the routing domain. We have to jointly use the, we propose the computing and networking metrics to do the first level of the work. Only after that, well, in the mobile space, I can say like the 3GPP, 5G, they have a defined, we can call the URSP, those type of things. That is some rule that are going to apply at the UE side. The things like people may argue about the URSP, say, okay, this is like a pre-configured rule at the UE, it's not dynamic, or it's configured by the PCF. It's not dynamic either, but there is some third ways, like in the edge computing, like Peng and Louis mentioned, in the edge computing, the domain, there is another called AF guidance. So basically, it does have some sort of intelligence, and the AF can provide intelligence to where NEF and to PCF, and then to the UE for this type of, although it's not completely real time, but it does have something like that. But since for AF guidance here, as ASP costs, for the mobile operator, normally they're going to provide the service. It's also like a ASP, or maybe contract with some third-party ASP. So the CAN, that actually is the good. You raised a very good point. It's like, okay, those information has to be collected. Something has to be collected and then do some intelligence and go through the AF. The AF tell the 5G system, and 5G system tell the UE. So the whole thing will connect together.
So this is all aimed at 5G. This isn't aimed in any way at fixed line broadband.
Right, but the thing here, you mentioned, okay, you're going to tell the UE or tell some other device about the things. No matter what, some intelligent things you have to get first.
Yeah.
Okay, and then tell. But who tell? Okay, you're not going to ask any device or UE to say, okay, can you do yourself purely? No, it's not. You cannot do it. Remember the client-based solution we have analyzed.
I think we should cut the discussion. We have so many people on the line. Maybe you can reserve your discussion to the charter. So sorry for that. Next one is Greg.
Yes, thank you. Greg Mursky, Ericsson. Actually, interesting. I think I changed my question standing here and listening to your discussion. Because originally what I was about to ask is the balance. So what you include in the term of continuity of the service. Because on one hand, you say that you want to update information using dynamic data. And that brings concern about the stability of your system. Okay, so that's the question about whether you consider that continuity includes the stability of your domain. Second, I think it's a larger one, continuing the previous discussion, is it appears that the scope of this work is not IETF specific, it's more for 3GPP. And when we started discussion of transport network slices in IETF, we clearly identify the scope of this work. So had 3GPP asked IETF to work on this? Thank you.
Okay. The first question regarding about the SSC service and the session continuity here, the things like is we just use the roaming as one example. Since the UE roaming will be very common case, it doesn't matter if the 5G or 4G or even about the 3G part. So the thing is here, we want to get some service affinity. So basically, like we always want to get the same in-service instance that is going to offer the service for the end devices. for the device. If you talk about the SSC, particular for 5G, since you mentioned about for the mobile device there, it has defined 3 different SSC. They, like I say 1, 2, 3, and they're going to have a make before a break or make after break. Those type of things. So, but the things like if you use the different SSC mode, and then you can still use like the PSA UPS, and then those type of things. But no matter what, they're going to boil down your second question. This is not 3GPP work. Remember, I keep saying, okay, that is just one example. So you are still going to collect information from beyond your N6 interface, and that will be on the DNN. So that is still going to include the collection of information, the signaling of the message, and then some intelligence that has to be applied as a networking node. Only after that, we'll be able to consider the use case in which 5G or 3GPP can be one. Thank you.
Let me cut in 1 second. Tianji, there is the a charter presentation, and then we have the open discussion. So you want, you can stay here. You want to
maybe charter. That's more important.
You want to control how much time you you spend on answering questions or comments, or maybe say that bring some discussion off and on or to later discussion. Just a reminder.
I think let's go to the charters. In the charter, also going to explain something about like the problem scope, objective, background, and then the timeline, all those things. And then after that, we still have sufficient time for open discussion.
Okay, so the next one is Chen Li.
Okay, I will make it very quick. Chen Li from Huawei. I do see the value of the gap analysis. Different solutions have different value, and we do see the value of the gap analysis. And by the way, we have answered again the similar questions raised today, no matter in the checkbox or here, right? So I encourage people to read the drafts and then go back again, because it's really hard to explain in the short term. You waste a lot of time for us, right? Thank you.
Okay, thank you.
Okay, so next one is Daniel Huang.
So sorry to interrupt.
Okay.
I think that do you want to make these? I mean, there are people in the queue, but I guess I'm going to request that people take themselves out of the queue if they have a general comment, and leave themselves in the queue if they have a clarification question about what you just presented. And everything else, you know, like Jeffrey said, there's going to be a charter discussion and a general discussion.
Sure, let's go to the charter part. Well, that will be more important. Yeah, we are going to have sufficient time after that. Thank you.
Okay, so is Daniel still there to ask questions? And Dirk as well?
Yeah, yeah. Daniel Huang from ZTE. I'm trying to be quick. And when we're talking about the off-path solutions like TNG presented in the drafts, and it seems to me it makes sense. Why it makes sense to maintain the computing related resources in the concentrated centered data centers, and to make the concentrated data center to make the service distance to selection decisions. But when it comes to the scenarios, well, the computing resources has been distributed and located in a multiple and locations in a quite ubiquitous way, and it seems to me it will be more better and reasonable to upload the decision process into the routing protocols and routing systems. Thank you.
Thank you.
Okay, so Dirk, do you still have something to
Yeah,
add?
quick clarification, Dirk Ross and Huawei. I can also encourage what Sheng said before, please read the references. We have references on a question regarding that Tom asked about what needs to be signaled. There are references to works that have shown that signaling very minimal information, and not semantic rich information, can give you significant performance benefits. We have a site meeting tomorrow, on Wednesday,
showing some work that's referenced in the gap analysis draft, and how you use the same algorithm at layer 7 or layer 3, and what are the differences. So it answers some of the questions of the gap analysis. If you do even compute awareness, and you do it at layer 7, what's the performance benefit or the performance penalty compared to if you do it at a lower level? It's discussed in one of the site meetings. So I encourage people to read these things, because they do answer to a large extent the questions. Thank you.
Sure.
Thank you.
Dirk.
So should we go to the next one on the agenda for the brief charter discussion?
Before the charter discussion, one clarification I want to make here. So indeed, some people believe that there is solution outside routing. And indeed, we're not going to talk about solutions here in this path, but indeed, this path is focused on the routing side. So that's what you're going to see. The charter is about the routing aspects.
Okay, it's the scope and the charter statement for CAN. So here, just to clarify our very important issue that CAN is about the ingress solutions, not to put everything in the underlying routing system. The CAN working group is a home to discuss how computing-related resources, including but not limited to computing and storage capabilities, may impact the routing system. Therefore, new mechanisms and protocol extensions may need to be developed to address the requirement identified in the WG. It's overall about the CAN-WG. And next is about the background and the motivations and some brief use cases here. So most modern service create multiple service instances that are often geographically distributed in multi-sites, including on-premise or cloud data centers, to scale up the service offering for improving performance, as any of those sites can serve a service. The computing-related conditions at those sites are just as important as the network conditions driven by routing protocols and traffic engineering for the service performance. This is especially true in edge computing environment when supporting services such as VR and AR and intelligent transportation, whose traffic may need careful steering due to latency, bandwidth, required computing resource sensitivity, and mobility. And therefore, joint consideration of network and computing resource status is needed for runtime traffic steering among multiple edge sites, as well as potential service deployment and resource management to meet the demand for optimal user experience. Okay, next slide, please. So there are existing solutions that utilize endpoint resource information for selecting the server instance, such as DNS Auto or Layer 4 and Layer 7 load balancers. Common to all those solutions is exposure and usage of network conditions for decision making, while none of the existing solutions integrate the computing resource conditions with the network condition for deciding on the optimal path. Here, I want to emphasize that some people goes early into the solutions discussion. So please to think more about the gap analysis part to find CAN's use case and its scenarios. So CAN allows ingress nodes to consider computing-related resource conditions in routing decisions. As such, the CAN-WG may develop an informational document or create a design team to define use case, gap analysis requirement, characterization of the computing-related resource, and how those conditions impact the ingress node's routing decision process. The finding will enable the CAN-WG participants to also study the suitability of existing routing technologies, such as BGP. Further, the potential for extending existing technologies to signal computing information in addition to network conditions will be studied. And for some existing technologies such as auto netcom, OEM, and emerging telemetry proposals will be investigated as for the purpose of joint computing network information collection and usage, so that the fault configuration, accounting, performance, security requirements may be met. Yeah, next please. So the CAN-WG is chartered to work on the following items. First, the groundwork may be documented by a design team or via a set of informational internet drafts and not necessarily for publication as an RFC. Includes a problem statement for the needs for considering both network and computing resource status. Use cases for using the network and the computing resource status to benefit the steering of traffic from applications that have a critical SLA that would require the integrated considerations of network path conditions and computing resource. Requirements for commonly agreed the computing metrics and their distribution across the network, as well as appropriate frequency and the scope of distribution, and analyze the suitability and usefulness of the computing and network metrics for traffic steering decision in CAN with the CAN metrics ontology as a possible outcome. And final of the groundwork is to analyze the methods for distributing the necessary information to utilize identified metrics in CAN use cases. And besides the groundwork, it also has applicability of existing tools and mechanisms. Analysis of implementing the CAN control and the data plan using existing mechanism, including identifying the limitation of existing tools in fulfilling requirements. Study potential new approach for the CAN control and data plan solutions that can fill the identified gaps of existing tools and solutions, and study the FC AP and suitability of existing message protocols such as netconf and the data models such as YAM. Next slide, please. So here's milestones. If the WG is chartered, plans to adopt the CAN problem statement, use case, gap analysis, and requirement document in June next year, July next year, yeah. And then adopt the CAN framework and architecture document, then adopt at least one control plan protocol document, and the data plan protocol document if there is, if the work refers to the data plan, and then submit the framework and architecture document for publication, and adopt the CAN OEM performance management YAM protection document, and then submit all of them in the few following maybe 4 or 5 years. All of this. It's current milestones. Yeah, it's all about the proposed charter statement, and maybe now it's open discussion or some.
Okay, I do want to say a few words before we start the open discussion. As you can see, there are 22 people on the queue, okay? So if you have expressed your opinions already, you can save the time for people who haven't expressed opinions. We want to hear diverse opinion from wider range of people to express. Okay, so just keep your questions short and don't repeat the questions you already asked.
Yeah, I'm sorry. Can you clarify your suggestion so that those who already spoke at the microphone will be punished for speaking early?
No, it's not punished. It's just the same questions.
Oh, okay, penalized.
Okay. Okay. So just because we have limited time, right?
I
Also,
don't
everybody
find
will.
it reasonable.
Okay, always make sure you can send emails, express your opinions on the mailing list as well. There's a can@ietf.com. So I will want to hear more opinions, okay? So let's go through the list. First one is Tony Lee.
Hi, Tony Lee, Juniper Networks. Right at the start of your charter, you made the assumption that you're going to fix this in the routing subsystem. And yet I've also already heard that not everyone agrees that it needs to be fixed in the routing subsystem. So I think it's a bit premature to assume that it's going to be fixed in routing. And I think the charter should be generalized. Thank you.
Okay, thank you very much. Next one's Greg.
Yes. I have a question. So you point to computing and storage capabilities. In the terminology of IETF transport network slicing, do you consider to be service level objectives or service level expectations?
Service level objectives or service level?
Sorry, it's about the network slicing or?
No. In your proposal, in your charter, so you're basically quoting that discuss how computing-related resources, included but not limited to computing and storage capabilities, impact routing system.
Yeah.
So these capabilities or requirements that set forth by the service, do you consider them to be service level objectives or service level expectations using the terminology of IETF transport network slicing?
I got the question. In fact, we have some work to discuss it, but we don't put the draft here in the book because it's not determined. I mean, in the chips level, service level, or service level may be possible, but it depends on the solution part, I think.
I'm lost. So do you consider that these capabilities are measurable or not?
Yes, it's measurable.
Okay, so if it's measurable, then probably most likely it's a service level objectives. And then why you believe that they are special comparing to latency metric, jitter metric, packet loss metrics? So why they do not belong in the framework of IETF transport network slicing?
Okay, so
okay, that's my question to the group.
Okay, thank you. So maybe you guys can think about it and answer on the mailing list. So basically, they're saying why it's not integrated with the jitter and other delay attributes. So
yeah.
Okay. So Greg, also make sure you record your question on the notes. So for them to, you don't have to speak to say because
right. I promise I will look up the minutes and I will.
You can do it now. Yeah, you can put in your questions clearly, right? Because quite a few people are non-native speakers. Sometimes they cannot react very quickly or listen clearly of the questions. Okay, next one is Sharon.
Yes, hi. Thank you for the presentations. I actually agree with a lot with what was presented. The challenges are real and concrete right now, and also it's not just a challenge, it's an opportunity because the geo-distributed compute resources increase the capacity significantly, reduce the cost, and they're not equivalent because they're geo-distributed. They cannot share a microsecond database, so they are not the same. So because of the applications and the changing loads and because of the geo-distributions, services actually may show up behind any PE in any of these locations. And we've seen that. And also clients may show up behind any IP anchor because of breakout and cost reduction and private 5G and Wi-Fi and also. And I also agree with what was said with the gap analysis. Load balancers are not the solution because they assume some concentration and we don't want to concentrate. DNS is a big caching issue in the client and the resolution breaks service. And any client-based solution will aggravate any coherency challenge that we still have if we solve in network, but not to the same extent. Not from millions, it will be reduced to dozens. But the problem, even though we're only discussing the problem, you can state the problem such that we need routing in network to be able to handle the fact that clients can show up with the same identity behind any PE, and so do services. They can show up with their identity behind one PE, and then in the next meeting behind another PE. So if the problem is stated that way, the gap analysis should also consider the routing that allows it today. So it's missing. Thank you.
Okay, thank you. Very long question, so thank you.
Yeah, I want to cut in for 1 second again. Please, if you're in the room, use the on-site tool for 3 things: blue sheet sign in, join the queue, and then at the end we may do a show of hands poll. So if you want your voice to be heard, please use the online tool.
Okay, next one is
Cengiz, I'm Wim Hendricks from Nokia, but the tool didn't like me, so he basically put his hand up for me, so that's why I'm in the queue. Yeah. So I have a question. So far in all the use cases, we drawn basically a set of computes and one network. Is the scope of what you're trying to do limited to a single operator network and a single owner or operational guy that owns the compute, or is the solution focused on the fact that I can have multiple operators owning the compute and different operators, not limited to one, owning the networking side? Is that in scope or not?
Well, thanks. First, we focus on the use case that both of the network and the computing results may belong to the same entity. That is simple use case, I think. And
okay, because in my view, if you look to the problem space today, it's constraining it to that is not practical. Because if I'm a user of an app, I will use multiple network operators and I will use multiple computes. And I think that's the space that we have to solve this problem. And then if you look at that, routing is the wrong space.
Yeah.
And I think that's how I look. I'm not saying that the problem doesn't exist, but if you look to the elements that are involved and that have to deliver the service, you cannot constrain this to a single network operator and a single owner of the compute. We have to think about this much more broader.
Yeah, thanks. In fact, we don't include.
Okay. So next one is Gan.
Charlie from Huawei, personally, I don't agree with that. We should do or work from multiple operators. That would make the thing very complicated, right? So let's start with a single operator, a very easy starting point. Yeah. So I agree with the charter of the use cases and the work items, because it clearly describes what we should do in the potential working group, right? So thank you for the work. And by the way, I need to mention this, in this both, we're following the instruction that we should not discuss the solution related topic because that would be an endless discussion. So we will get nothing today. So let's focus on the use case. Thank you.
Thank you. So next one on the list is Dirk Troelsen.
Hi, Dirk from Huawei again. And I wanted to keep it short because I was already in the microphone, don't want to get punished. But I do agree with Sheng. I mean, we put a lot of work in trying to make a case, but I think, Wim, that was not, right? Right, good. Hopefully we note this properly, that somebody actually disguised himself. I think you had a good point, though, and this ought to be part of the discussion. And maybe some of the use cases are too constrained if they're only considered in a single domain. I generally don't agree to that. That's getting boring. But there may be use cases where maybe spanning both compute service providers and network providers may be interesting. But again, only a good discussion on the use case and the problems will bring that out. And that's, for me, even more an argument to do this working group moving forward and work on this properly. So I certainly support this. Thank you.
Thank you. So next one is Tianji.
Here, I try to answer the question. I forget who asked about the use case. And as Peng has answered already, so far we are going to focus on a single domains, like not going to cross some operators. But the thing is, if you look at the work, look at the thing we have laid here, it's not going to prevent us or prevent the community from doing the cross operator things. So that's why actually, well, when you talk about cross operator, it does require the standardization. Actually, that is our objective, to make this one standardized through a CAN working group, such that everyone can work together across the operators. Thank you.
Yeah, thanks.
Thank you. So I will already close the queue because too many people. So next one is Yuxia Fu. Is she on the remote? Okay.
Yes, Chair. And I think there are many ongoing work related to the computing and network convergence, and there are also many requirements. And we think that the use cases and also the problem statement is clear and it's meaningful to working on that. And also the charter is clear for us, and we think that we need a home to discuss the related issues. So a new working group may be better to promote the work. Thanks.
Well, thanks.
Okay, next one is Xuewei Wang. Xuewei, you're on the.
Oh, hello?
Yes, we can hear you.
I'm from Radio Networks, and the scope and the work items which the chart laid out are very clear to us, are also very important. These issues has been discussed a lot past in the CAN and the discussed mailing list. So I think maybe we need a working group to promote the works. Thanks.
Thank you. Next one is Rolling Wang. Jing, right? Jing, sorry.
And in my view, the charter makes it very clear, and the establishment of the new working group is of great significance to the promotion of the computing-aware related work. And our research group is also engaged in related research and often hear this, and we are looking forward to the future work of CAN in IETF. I support the establishment of the new working group. Thank you.
Okay, next one's Wei Chang Chen.
Hi. I think the use case support access to the available edge computer dynamically. The scenario is valid. And I think the charter is clear. So thank you.
Okay, next one is Keaton.
Hi, Ketan Talaulikar, Cisco. I think there is still not clarity, at least in my view, whether what is exactly the problem to be solved, and as a follow-up, whether the solution is at the routing layer for that. So the charter talks about things like, or seems to talk about things like path selection, right? Using some additional metrics, perhaps, for traffic engineering or tunneling, right, to the right egress point. Those are all probably things to be done at the routing layer. But then the use cases and other things and the comparisons give me an impression that that's not what this is about. This is more about a selection of the address, because we are talking about load balancers and alto and all those things. So I'm to me it's not clear that there is a what the charter is and what the problem is going to be solved, and whether it's appropriate to solve at the routing layer.
Thank you. Minggu Wu.
Okay. Minru from Centec. From the charter, I think the use cases of CAN are very interesting and indeed makes sense in delay-sensitive scenarios and highly dynamic network environment. And I think solving these problems by modifying layer 3 protocol may be a good option. Thank you.
Thank you. Next one is Gao Kun. Gao Kun, are you on the line? You can speak now. No? Okay, then next one is Dhruv.
Hi, Dhruv. Regarding the discussion about how to handle multi-domain, I think we have to start with single domain, but we could always put this in the charter that whatever solution that we come up with should be able to handle in future multi-domain. We have done that in the past as well for various things. And I think we have to start small, but have a way of rechartering for multi-domain in future. And going back to the original point from Tony, can we keep the charter of the working group without constraining it to routing? I think it's going to be very difficult. We have gone through those cycles over and over. We need a starting point, and we need to constrain that and we have to agree based on the gap analysis. That's the key, whether there is a consensus that what has been highlighted in the gap analysis and the solutions, which could be alto based, load balancer based, are not going to meet the requirements that the proponents of the BOF are making. And if we have an agreement on that, then we can definitely say that we need a routing based solution, and I'm looking forward to that. Thank you.
Thank you. So next one, is Gao Kun on the line? No. Yuan Xia Qu. Okay. Yuan Xia, you are on the line.
Can you hear me?
Yes, we can hear you.
This is Yuan Xiangqiu from New H3C Technology. I think the use case and this charter is clear, and I think it will be better if a new work group was formed to promote the work. Thank you.
Okay, so next one is Zhenbing.
Okay, Zhenbing from Huawei. Okay, in fact, I be shepherd for this BOF that for a long time. So regarding this charter and also some of the questions, I have this following comments. The first one, I think regarding this charter about these use cases, in my opinion, I think that the edge computing and VR and AR is just the example. I think maybe in the charter can be generalized. In my opinion, I think this is the consensus to some extent is to advertise this computing information to the network. But the use cases can be beyond the AR, VR, and this edge computing. Because in my opinion, for example, in the SD-WAN, this CPE device maybe can also use this information for the traffic steering for the SD-WAN. And also maybe that's the SFC, we can, according to this computing information for the service training, I think this is the path. So in my opinion, but because many discussion is always about load balancer and about the edge computing, AR, VR. So I think in order to that is for this consensus and generalization, in my opinion, I think the use cases or this mentioned in the charter should be generalized. This first comment. Second one, I think this is wide network nodes. So I think in fact the load balancer maybe that is the load balance. This is the original IP packet. But for the network node, when we receive the packet, we may encapsulate the tunnels for the traffic steering. So this means the network node can take use the computing information for the load balancer, for SFC, for maybe other SD-WAN, etc. So this is why we network node can learn this information. Maybe this is for more application scenarios. This is second point. A third point that people talk about this application level or service level, this is the matrix information. in my opinion, so this is just this is the work item we should take into account. So this is some people talk about this common matrix. This common matrix we directly use the delay or some this is the bandwidth or some this like this one, or we use the application level or service level, or directly based on the S this level. So I think this is just open. I think this is why we discuss, we set up some this common matrix. So this is the third point. And this is the large point. I think this is scope, and this is discussed about, in my opinion, this is the edge computing, this is the typical scenarios. I think the cloud, and this is the cloud and the computing, and this is the network can be controlled by one operators. But I think this has no effect to define the common matrix. So from my opinion, maybe I also confine this scope to this the computing and this network in one operators from the beginning. So later maybe think about more complicated scenarios if this involve these third parties, so that we must discuss more about the security or maybe some other work may be done. But I think current space, I think if we consider to learning this computing information and set up this matrix, and think this is, I think the scope can be confined. Okay, that's all.
Thank you.
Thanks.
So next one is Daniel Huang. Is Daniel on the line? No.
Yeah,
Okay, then go to
yeah.
the next one.
Daniel Huang.
Oh, sorry.
Daniel Huang from ZT. I'm sorry. Daniel Huang from ZT. First thing I'd like to make a minor clarification about the charter, which is the statement about the exposure to networking resources. Actually, it occurs to me in the industry there is also exposure to computing resources when it comes to DNS and GSOB solutions. Something like that. What is absent in the industry is actually the joint optimization and exposure to networking computing resources. And again, when it comes to the situation where the computer resources is more and more distributed and ubiquitous, I strongly believe it should justify some capability enhancements in routing systems to make it adaptive to the new established norm, in which the computing resources is more and more distributed. Thank you.
Okay, thank you. So next one is Adrian.
Yeah, I'm from Taiwan Telecom. I think the network has been in one closed loop status for a long time, and for IETF we have invented many tools to improve the network performance, but the end user and the application server cannot feel our effort. I think it is time to open the network and incorporate other information to improve the performance of the application server and all the end user experience. Okay, and one small comment for the milestone. Would you like to switch to the slide?
Milestone.
The milestone slides? Okay.
Milestone.
The milestone.
The previous slide.
Yeah. Milestone. Okay. Yeah. Okay. Here I noticed that the CAN will develop one control plane protocol and the data plane protocol. I think the control plane and the data plane protocol should be belong to the other existing working group within IETF. So I think the CAN should be focused on mainly on the framework and architecture document. Okay.
Thank you. The next one is Dino.
Thank you, Linda. No, I'm not Dino. Dino has very nicely offered to let me use his slot because I put myself on the queue right after you closed it.
I see.
I'm Joel Halpern from Ericsson. So I have a couple of different reactions. This charter needs to be cleaned up significantly before it can be brought forward. There is a real problem, a real task, a real thing that I think is worth working on here. So if we assume that ingress devices providing tunnels or in caps or whatever to get traffic across the network to the right server is something people want to offer, which seems sensible and desirable, then making sure there's a way for servers to provide information such that it can get to those ingress devices and they can make choices that use the service information and the network information, because as an ingress router, they see the routing already. That makes sense. But when you talk about injecting the information into the routing protocols, I go ballistic because it doesn't make sense. It doesn't work. And there's no need to mandate a data plane protocol because that's not what we need to do. We need to focus on getting the right information to the entities that can make the decision. You've said on the list, and you said when you started the presentation, this is about the ingress devices being able to make the decision. If you write the charter around that, I think we have something we can work with. We can then figure out what area it belongs in. I don't care. Yeah. But saying in the charter, we're putting the information into the routing system gives me serious heartburn. Thank you.
Thank you. So next one. Next one is Colin.
Could I clarify?
Yeah, please do.
Yeah. Hi, John. We have discussed these issues, and I think it is the most important issues from the previous BOF that won't really expect the whole routing system. It focuses on the edge router, and if the current version of the charter will lead the misunderstood of this direction, we can work together to refine it, I think. Yeah.
Okay, so
Colin Jennings with the IAB. And John, these comments are mostly for you, I think, really. When I read these milestones, this is very much about a solution. We can't be having this BOF where we say we're not discussing a solution when the charter is very much about a solution.
Okay,
and no, do not cut me off. Thank you very much. And the issue here is, so that's part of the issue, and the issue is lots of people are saying we should do this at the application layer, and this is regularly done at the application. Major SD-WAN solutions, major VoIP solutions find through DNS or other mechanisms a variety of endpoints, then they contact each one of those endpoints, measure latency, jitter and stuff to them, and also at the same time get information back about their compute, memory, availability they have of the resources that are important. So this is a real problem, no question about that. But there's solutions to this that may work very well. They're done very much at the applications. I don't think these problem statements have been taken over to the dispatch or the application or art area and discussed there. You'd get some very interesting feedback on how people think we should solve them. Now, I'm not arguing that means we shouldn't do something here, but we can't do something here without discussing the architectural issues of the solutions in the routing area versus the application area. And just denying that discussion in this BOF means we just can't go forward with this charter like this. Thanks.
Thank you. So maybe you guys can think about it and address that, okay?
Yeah.
So next one is Dean.
Yes, hi, Dan Bogdanovich. So I'm in a very strong agreement with Joel and with Colin. If we want to set up a working group to define the problem, very happy to do so. Resource information sharing across, let's call them IT systems, is something that would be very nice to solve. Is it the L3 or the L7 layer where to solve it? Is it a combination of that? We don't know. There isn't a real clear problem statement, what has been presented here, what has been presented in the APN, and the closest person to come to the problem statement definitions were Colin and Joel, and I agree with that. So let's set up a working group to define the problem and then to solve it. Once we define, once we know what problem we're working on, we can then find the solution. Right now, there's no problem statement.
Okay, thank you. So next one, Paul.
Hello, this is Paul Jiang from Songyang University.
So I have three comments. The first one is can both can consider energy consumption. Looks like basically energy consumption is very important the viewpoint of operators, right? So currently the can both don't consider energy consumption. So that is a first comment. Second one is as another use cases, as you can see, urban air mobility, like the cars, right? So the Hyundai automobiles, they are tried to commercializing by 2018. That is very important. So you mentioned some autonomous vehicle. In addition to that, also we consider prime autonomous vehicle or something like that. That is the second some use cases. The third one is some proactive edge server assignment, considering the users moving the trajectory, right? Because you can see, especially UE or the car is moving according to road ways, we can proactively assign resources in proactive rather than reactive way, right? So that is one thing. Also, users can usually prefer some the applications. The application requires some bandwidth and delay. So that kind of power information can be taken advantage for our CAN-BOP. I think the CAN-BOP is very important, I think. Thank you.
Thank you.
So next one is Tianxin. Tianxin, are you on the line or are you in the room?
Can you hear me? Yeah.
Okay. Wow.
I support the charter. It is clear and a good start point to make a further job about it. And thank you.
That's it? Okay. So next one is Ling Han. Ling Han, okay.
Hello. I think the charter is valuable and clear, so I support the charter. Thank you.
Okay, so.
Okay, so we had closed the queue earlier. I see we still have many people in the queue. So I think at this time, we can let John, our AD, decide when he wants to cut in. We can continue the queue until when John decides that it's time for him to step in.
Well, I don't need a lot of time for monologuing. Give me, 5 minutes at the end. I think you guys had prepared some questions you wanted to ask, so make sure you leave yourself enough time for those. But yeah, just save me, 5 minutes to close with.
Sure. Okay.
Should we do the poll then? Bring back to the chair.
Yeah. Okay. So we are going to do the poll at certain time. So if you are in the room, you have not signed in on the on-site tool yet, please do so. We will do the poll like in probably 5 minutes or something like that. Then right now we'll just continue the queue. Yeah.
Oh, you want to continue? Okay. So next one is Rang.
So for clarity, in order to answer the poll, you need to make sure you've signed in using the QR code there. And then there's, once you're signed in, when the chairs start a poll, it'll pop up on your mobile device or your laptop.
I think we should do now.
So Rang, are you ready to talk?
Okay, I'm Yang Pang from China Income. I think the data is valuable. We also have some solutions with this use case, and I'm willing to participate in related works. So I support the new working group. Yes, thanks.
So can we continue or should we start the poll? Continue. Okay, next one is Gao.
Okay, I met the similar scenario and requirement previous in the service of an Europe telecom carrier who is also has the public cloud service. and they have the latency requirement on the network in the service of Barcelona. And I even made this kind of case in the public cloud carriers service in China. The typical scenario is under the computing and storage separation solution. So I think the requirement of network to provide service according to the computing resource allocation of the region, and even the service calculus is start to appear gradually in the recent years. So maybe it's the right time to start doing the research on it. Okay.
Okay, thank you. So next one is Kenji. Do you want to withdraw? Okay. Okay, the next one is Cossack. Cossack, are you online?
Yes, I am online. Can you hear me?
Yes, we can hear you. Yes.
Thank you for hosting the CAN Bob. I just wanted to mention that like the use cases are valid. It absolutely makes sense. The service metadata need to be distributed to the network edge, especially on the WAN edge, for better decisions making and kind of having a better performance throughout the network. So the use case standpoints, it's completely makes sense, and we should do a single operator initially. The how we do that solution wise, that's to be kind of need to be looked like if it is involves the routing and kind of that maybe that there are if it's kind of a existing work group, we could look into the some existing solutions for that and the routing group, right? So that's anyway. I would be kind of happy if for the use cases, if anything needed, my help. Thank you.
So Cossack, can you state your affiliation?
Sure, I'll do that. Thank you.
Okay, so next one
Oh,
is
my affiliation is with the Microsoft.
you can do it on the notes or you can say it either
Okay.
way. Jianwei.
And hello, my name is Jianwei Mao and from Huawei. And I think the use cases are valuable and for the near future. Introducing computing information will provide more chances to network routing. The problem statements, objectives, and the milestone are clear. I expect to see this working group is formed finally. Thanks for your work. Thank you.
Okay, so maybe we let Robin Zembing to say something. He's a SharePoint AD. Then we.
Okay, Zhenbin again. In fact, this I missed this the milestone. From my point of view, I think if this we have the consensus, so I think the first, I think the work we should define some this the common matrix about this computing infra. I'm not sure if this included in the framework dropped or not, but in my opinion, so I think it's better this can be identified independently. I think this is one thing. The second thing, I think here we directly talk about the control plane and the data plane. I think maybe we after this the metrics can be defined. We also can like maybe 10 years ago we know that the I2 I forget I2 RS. Yeah, we can do some of the discussion about the protocol choice. So that's after that we can can get this the consensus. So then we can go on to discuss about this the control plane or data plane solutions. That's my comments about some suggestion about this milestone. Okay. Thanks.
Thank you. So Dino, that's real Dino, right?
Really, Jolden give me a slot. So I'm not going to make a comment about if this should be made into a working group or if it's a good or bad idea, but I just want the group to think about this architecturally from a full stack perspective. And let me set up a scenario first. I'm an application developer. I'm going to write a bunch of code. I have a lot of things I have to worry about. How I use my local CPU, memory management, data structures, number of threads, what APIs I use. I have a lot to worry about. So I have my local compute resources I have to worry about. And normally I didn't have to worry about network resources. Now what's happening is there is a burden on me to just tell the network what to do. Let's rewind 20 years back. The TOS bits in the IP header were there so the application could say how the packet should be handled, right? We could have back then said the network should tell the applications how to set the bits, but we never did that, thank God. So now what happens is if the applications would have set the bits, like EF and AF used quite a bit today for audio and video, then the packets could be handled, especially for these specialized applications. Maybe AR/VR has to have different bit settings than audio and video the same, or we have to figure it out. But I have a feeling that if this group builds something for applications, the applications are just going to ignore it because they don't. In fact, you may give me all this information and I'm saying, oh, this is great. Now what does it all mean? If I tweak this and I tweak that, how's the network going to behave? Will the network actually deliver what I say? And will it deliver it at every single hop along the way to the destination? So I really think that this is going to be something that's going to have complexity and it's going to be fruitless. And I'm really worried that we're not going to do the best thing. You can't make the speed of light go faster. So the network's going to do the best it can. And it's going to have to make decisions quickly based on the resources and the size of the queues of what's going on at this instance. So we have to be really careful what you build here because it may just never get used because of its complexity.
Okay, so I'm going to cut the mic line here now. We are going to do the poll. On the screen, you can see 3 questions. I'm going to skip the third one because we know there will be many people interested in working on this. So we're going to only focus on first 2 questions. In fact, the second question, we're going to change it to, is routing the right group to attempt to solve it? Okay, so the second question is routing the right group to attempt to solve it. We'll go start with the first question. Does the community think that the problem statement is clear and well scoped? I'm going to start a tool. Let's see. What? Yeah. Here, just go back.
Yeah, you can go back to, go back to here to raise your hands, yeah. Okay. Is that recorded?
I'm going to read it out at the end.
So just let's repeat. So if you raise your hand, that means the problem statement is clear and well scoped. If you click on do not raise hand, that means you're not agreeing that it's clear and well scoped. And of course, if you don't do anything, that means you're just not doing anything.
All right, I'm going to end it now so that we can get to the second question. For the record, we have 148 participants entered the choice. There are 93 who raised a hand and 55 does not raise hand, which means that 55 or this change that people does not think that the scope is clear. Okay, so we are going to end this session now. For the second question is the routing group the right group to solve this problem? Let's start the session now. Again, if you raise your hand, you're agreeing that we should solve it in a routing group. And if you click on do not raise hand, you mean that you do not think routing group is the rest group.
Okay, two things. One is I have Greg muttering in my ear that he thought the first question was only, does the community think the problem statement is clear? And he thought that it wasn't, that well scoped wasn't part of that question. I had understood, this is always the problem with these polls, okay? They're approximate and, you know, they're not votes. And if you didn't understand it the way the chairs meant it, we probably should just move on. But on the question that you're asking right now, I want to emphasize or to clarify, we're asking, is the routing area the right area to be solving it in?
Thank you. Yeah.
So
right.
just Jeffrey had said group. So are we talking about chartering a group in the routing area? Or if you think so, then raise your hand. If you think that we should not be chartering a group in the routing area, then probably you should not raise your hand.
Thank you. Thank you. All right, I think we're going to end the session now. Out of 144 people, we have 90 raised hands and 55 does not raise the hand. Okay, so now we leave the rest of 4 minutes to John, our AD.
Thanks, everybody, for spending the last 2 hours in a room. We didn't actually intentionally get a room that was supposed to make you feel like you were being stuffed into a can. But I guess that's what we got. So thank you for your patience with that. So, you know, as usual, I need to go away and think about what I've seen and heard, but I can't ignore the fact that the biggest reaction that I heard in the entire 2 hours was to Joel's little mini speech. And I think that I heard that a bunch of times. And his 2 points, and you can yell at me if I summarize you wrong, Joel, because I'm not referring to notes. But the 2 things I heard from that were, one, yep, seems like there's this is what we heard last time too, by the way. Seems like there's a legitimate problem that people legitimately want to solve in a, you know, standardized way. But his point number 2 was, but maybe not in the routing area. And that's what I heard from Cullen also. And that's what I heard from Dan also. And that's what I heard from, you know, some of the feedback that was coming through on Zulip also. So there's clearly diversity of opinion in the room. The instrument that we just used to sort of, you know, take a hum, you know, demonstrates that there is that diversity of opinion. Right now, going out of this room, I don't think that I could, you know, in good conscience say we have anything like consensus to work this problem in the routing area. I think we got some very good advice from Cullen that there's a wealth of expertise in applications in real time that if we can, you know, engage the right people there, we may be able to get some extremely interesting feedback. I think that we should probably pursue that. And I think that I would like to find some time to talk with the proponents at some time later this week, but right now I'm not hearing consensus to create a working group in the routing area to pursue this charter as we've currently, you know, got it on the board. I am hearing consensus that, like I said, there's work to be done, but we need to nail down where and how and what. Oh, by the way, the other thing, one other thing that I heard is that there continues to be, you know, a minority of people that really would love to actually do something more radical, which is to, you know, work the problem in the underlay, and that we should, you know, yes, we should have the you know, the routing system trying to solve this problem. And the one thing that I heard consensus for more strongly than maybe anything else is that no, we shouldn't do that. Sometimes consensus is right, sometimes it's wrong, but that's what I think the consensus is. So that's what I heard in the last 2 hours. Thank you all for your work on this. Thank you all for your time. And I think we're concluded.
Thank you.
Thank you to the chairs for organizing and to all the proponents.
Thank you. So the meeting is adjourned.
Thank you. What is it? I don't think so, because they didn't mention any.